Cybersecurity in marine PLCs. How ABB and other OEMs protect critical automation systems. In today's connected maritime world, vessels are no longer just mechanical giants, they are floating data centers. From power management to navigation, every major shipboard function depends on programmable logic controllers, PLCs, and integrated automation systems. This heavy reliance on digital systems also introduces a serious risk. Cyberattacks. For ship operators, Electro-Technical Officers, ETOs, and engineers, ensuring the cyber resilience of PLCs is not just about compliance, it's about safety, efficiency, and protecting global trade. So how do leading automation companies like ABB, Siemens, Schneider Electric, Mitsubishi, Kongsberg, and Yokogawa make their PLCs cybersecure? Let's dive in. Locked ABB. Cybersecurity at the core of marine automation. ABB places cybersecurity by design in its automation systems, especially for marine, oil and gas and power sectors. Encrypted communication. Supports TLS and OPC UA secure protocols. Role-based access control. Ensures only authorized personnel can modify logic. Firmware integrity. Secure boot and digitally signed updates block tampering. Integrated monitoring. ABB Ability cybersecurity platform provides fleet-wide protection. Compliance. Aligns with IMO cyber risk guidelines and IEC 62443 standards. Locked Siemens. SIMATIC PLCs with defense in depth. Siemens is a leader in embedding security directly into its SIMATIC S7 PLCs and TIA portal software. Firewalls and encryption built into S7-1500 controllers. User management. Passwords and role-based access to prevent unauthorized changes. Signed firmware. Protects against malware insertion. Defense in-depth strategy. Plant security, network security, and system integrity combined. Used widely in ship power management (DP) systems and offshore rigs. Locked Schneider Electric. Modicon M580 and industrial-grade security. Schneider Electric's Modicon PLCs are built with Achilles Level 2 and ISA/IEC 62443 certifications. Encrypted data transfer between controllers and SCADA. Centralized authentication for user control. Secure development lifecycle ensures vulnerabilities are patched early. Common in power plants, LNG facilities, and subsea installations. Locked Mitsubishi Electric. Securing MELSEC PLCs. Mitsubishi focuses on network and controller-level security in its MELSEC series. Secure CPUs prevent unauthorized program uploads. VLANs and firewalls ensure OT and IT separation. Access levels restrict what engineers can modify. Used in auxiliary ship systems, power distribution, and factory automation. Locked Kongsberg. Maritime-focused cyber resilience. Kongsberg Maritime specializes in integrated ship automation with cybersecurity built in. OT/IT segregation. Critical ship networks are isolated from crew internet. Cyber monitoring. Real-time anomaly detection for DP and PMS systems. Marine compliance. Designed for naval, offshore, and LNG carriers. Locked Yokogawa. Industrial cybersecurity in action. Yokogawa integrates PLCs with DCS, distributed control systems, for heavy industries. Intrusion detection at the network level. System hardening, IEC 62443 certified. Process-safe security for LNG plants, tankers, and offshore rigs. Globe with Meridian's common cybersecurity practices across all OEMs. Despite differences in design, the leading PLC makers share a core philosophy. IEC 62443 compliance. The global benchmark for industrial automation security. Defense in depth, multiple layers of protection. Firewalls, encryption, monitoring. Patch and update integrity. Only signed firmware from the OEM. Network segregation. Isolating IT from OT environments on board. User authentication and logging. Ensuring accountability of every system change. OEM cyber defense centers. Remote support for rapid incident response. Anchor why it matters for marine engineers and ETOs. Even the most advanced PLCs are not 100% hack-proof. Instead, companies like ABB, Siemens, and Kongsberg design cyber-hardened systems that greatly reduce risks. But the final layer of defense rests with shipboard engineers and ETOs. Their responsibilities include applying patches and updates safely, managing crew access rights, monitoring for suspicious activity, ensuring network segregation remains intact. In short, technology provides the tools, but human vigilance ensures protection. White heavy check mark. Final thoughts. As ships become more connected, cybersecurity in marine PLCs is no longer optional. It's a mission-critical necessity. ABB and other OEMs are setting new standards with cyber-resilient automation systems, but it is the maritime workforce that brings these defenses to life at sea. A secure ship is not only safer for the crew, it's safer for global trade.